Hello, I'm Jason Innes. I'm the manager of training and curriculum development here at KinderLab Robotics. We're the makers of the KIBO robot, which is a robot kit for ages 4 to 7. This video will introduce you to KIBO. You'll learn all about the parts of the robot and how to assemble it, how to introduce it to kids, how to talk about it with them. You'll also learn how to program with KIBO, so how to write a program to make KIBO move or sing, and some techniques for successful programming and scanning with the robot. And then we'll also cover the Robot Zoo, which is our introductory curriculum for KIBO, which provides about 8 hours of classroom time and introduces kids to basic engineering, coding, and KIBO operations, and then invites them to show what they know by decorating KIBO to turn it into an animal of their choice. I'm going to turn it over now to Amanda Sullivan, who's one of the researchers at Tufts who was instrumental in the design of KIBO, and she'll show you KIBO's parts and introduce you to the robot.
So you'll find in your kit KIBO's main body, and this is the part of the robot where all of the other parts are connected. And if you flip this over, you'll see what makes KIBO really unique. It's got a see-through bottom, and when introducing this to kids, it's really important to point out that this isn't a magical device or a toy. There's really no mystery to how KIBO works. You can show them the wires that are inside, the batteries, and the main board, which is like the robot's brain or the main computer of your robot. Now if we flip it over, we can see different ports where things can be connected. So I'll go over some of those other pieces with you now. So KIBO comes with motors, so you can create a robot that moves on the floor, on your table, or around your classroom and home.
So you'll notice that the motor can be connected to the wheel in two different ways, like this or the opposite direction, like this. And you'll want to experiment with your kids to see how this changes the way your robot moves.
Now when attaching your motors to the robot body, you'll notice there's a green dot on one side of your motor. You'll want to be careful to orient the green dot facing downwards when you slide the motors in, just to ensure that your robot moves the way you expect it to. And you can actually have kids flip their robot over and double check that the green dots are visible through the bottom. KIBO also has a variety of sensors that can be attached. There's a sound sensor, which kind of looks like an ear, and it can sense whether you're clapping or whether there's a loud noise or if it's quiet. And it gets attached on top. There's a distance sensor, sort of looks like a telescope, and this can sense if something is near or far. Finally, there's also a light sensor, kind of looks like your eye, and it can sense if something is bright or dark. All of the sensors are attached on top to the ports at the top of your robot body. KIBO also comes with a light output. It's a light bulb, and depending on the blocks that you have, you can program your light to turn red, white, or blue. Finally, the KIBO kit also contains different art platforms that can be attached to your robot. This is great for kids to personalize, decorate, and create a robot that is personally meaningful to them. So we've got a static stage that can be attached on top, but we also have a motorized platform. It's connected to a motor, just like the ones we connected to the side of our KIBO, that can fit right on top. And that's it. Those are all the parts you'll find in your KIBO kit, and you're ready to start programming KIBO to move.
So that gives you a good look at KIBO and all of its different parts. It's very easy for kids to assemble KIBO, take KIBO apart, and interact with all of the parts, which is a very intentional design. We wanted KIBO to be very approachable and comfortable for kids. In fact, when you introduce KIBO to kids for the first time, it can be helpful to take the robot apart, give each kid one piece, and then in a circle setting, pass the robot around and ask each kid to add their part to the robot. That gets them comfortable right away with the idea that KIBO is made for kids to interact with. I just want to reiterate something that Amanda pointed out in the video, which is about the green dots being visible through the bottom of KIBO. As you can see, each motor has a green dot on it, and that indicates that the motors are inserted correctly when you can see the green dot through the clear bottom of KIBO. This is important because each motor has a direction to it. So if a motor is inserted upside down so that the green dot is not visible through the bottom, then that motor will actually run backwards when KIBO receives an instruction to move. So with one motor upside down and one right side up, that means that a forward command will actually cause the robot to spin in place because one of the motors will be going backwards. So if your kids are finding that one of the KIBOs seems to be interpreting its movement commands strangely, going forward when it should turn, or going backwards when it should go forward, just give a quick look at the motors through the clear bottom. Make sure that the green dots are visible. And if they aren't, then just swap it so that the green dots are both visible through the bottom. This can be something that you engage the kids in too. They can do this debugging with you, but it's an important troubleshooting tip to keep in mind right from the start. That's probably the most common confusion early on with KIBO is it seems to be turning when it should go forward or vice versa. And it's almost always that the motors are inserted upside down. Let's join Molly Elkin, another researcher at Tufts DevTech, as she explains the basics of KIBO programming and scanning.
Now I'm going to show you how to connect the programming blocks for your KIBO robot. Remember, every program must begin with a begin block and end with an end block. So today, I would like my robot to shake and then beep. You'll notice how the blocks are set up is I cannot put anything before the begin block or after the end block. To connect the blocks, I'm going to place the peg inside of the hole, and when I want my next block, I'm going to also put that in, and then I'm going to connect the end. Now I'm going to turn on my robot, and you'll notice the red light is flashing, which means my scanner is ready to scan the blocks. Now that I've scanned the program, I'm going to press the button and watch my KIBO move.
Just to go into a little bit more detail about what Molly said, here are a few tips to ensure more successful scanning, both for you and for your students. You'll notice, first of all, that the scanner projects a red line based on where the scanner is pointing. You don't need to hold KIBO so close to the blocks that the red line is the same width as the barcode. It's best to hold KIBO about 4 inches above the blocks that you're trying to scan. So the red line that KIBO projects will actually be wider than the barcode. So you'll see as I move, you can hear that sound, that beeping sound and the flashing green light right here. That's telling me that, that's KIBO telling me that it sees the block and it scanned it okay. Now, one thing that happens a lot when kids are scanning is that they'll scan the same block twice because they don't move on quickly when they hear the sound. So there's a few tips that you can try to help them be successful. One is to ask them to turn KIBO toward them so that they can see the green light flashing, because KIBO, when KIBO successfully scans a block, it beeps, but it also flashes that green light. So if kids are looking for both the sound and the flash, that helps them know that KIBO scanned the block that they were pointing at and they can move on. Another trick is to have them tilt the KIBO onto the barcode, and then as soon as they hear the beep, move it away again. Like that. So they're moving down the line, scanning each block in turn. Now, another trick for kids who are having trouble with scanning, or who are maybe double scanning or scanning the block next to the one they're trying to scan, is once they've created their program, you can ask them to actually separate the blocks a bit so that there's more space between each block. That makes it a lot clearer for kids who are just learning how to use KIBO. It makes it clearer for them which block is being scanned. So that's a good trick. Once you've scanned the whole program, including both the begin and the end, then the green light in KIBO's triangle button will start flashing to let you know that there's a correct program in memory and KIBO is ready to run it. To run the program that you've read in, you just press the triangle button, and KIBO will run the program that you just loaded. So KIBO went forward and then backward. If we want to run the same program again, we can just press the triangle button again. Kids don't have to rescan the same program. But if we want to change the program, then we would add a new block or change the blocks. So in our example, let's add the shake command in between the forward and back. So I just add the block to my program, then scan it again, starting with the begin and ending with the end. Now when I run the program, KIBO will do the new command at the point in the sequence that I chose. Forward, shake, and then backward, just like our program set. If you have a KIBO kit of your own with you, now would be a great time to pause the video and just try scanning a few programs and running them. Remember to hold KIBO a few inches away, wake it up with the green button once. If it's already awake and the red light is flashing, you don't need to wake it up again. You can just start scanning. Write your own program make sure to start with the begin and end with an end, and see what KIBO does. Now, how about some of those other parts that we talked about before? The KIBO eye, the light bulb. Let's talk about that a little bit. So we can attach the light bulb to our KIBO, and that lets us use some of these additional blocks, the light bulb blocks. The light bulb that's included with KIBO can light up white, blue, or red. So let's write a program that includes the light bulb. I start with begin, and I'll end with end. In between, I can use all three light bulb blocks. So let's try scanning that. I've told KIBO to turn the light bulb on white, then blue, then red. So no movement this time, just output with the light bulb. Your KIBO kit includes a lot of additional programming blocks and parts. I'm going to talk about a few more of the parts that are useful when you're first working with KIBO with kids. There are additional parts that we won't go into detail in this video, but KinderLab has a tutorials video website that explains all of the parts, including the more advanced ones. So I'll share that URL with you, and we'll also have pointers to it at the end of the video. But just to cover a few of the other important blocks that you may interact with, or that students may be curious about during some early investigation with KIBO. We already looked at some of the movement blocks, forward and back. There are also turn blocks to allow KIBO to turn left and right. Of course, that's important to be able to make KIBO move around the classroom. There are also a few musical blocks that KIBO has, a simple beep sound and a sing block, which causes KIBO to sing a sort of musical tone. Those are great for telling expressive stories using KIBO. The first of the blocks that I want to talk about that actually uses some of the sensor parts that Molly explained is the wait for clap block. Now, what this does is cause KIBO to pause its current program until it hears a loud sound, like a clap, but other sounds can trigger it as well. In order to use the wait for clap, you have to have the sound, the hearing module, the ear, attached to KIBO. So this allows you to introduce the concept of sensors, which is a fairly advanced concept for kids. but it's parts like our own human senses that allow us to perceive the environment. KIBO can do the same thing using its sensors. This looks like an ear because it works just like our human sense of hearing. So if I were to take the program that we had earlier, where we turned on the light bulb, and include the wait for clap, let's say we want to put it right in the middle of the program. So this program now says, after the begin, turn on the white light, then wait for a clap, then turn on the red light. So let's scan that program in. And then we'll run it. So first, KIBO's white light will come on. Then the red light comes on only after KIBO hears a clapping sound. So this allows kids to start exploring ways that KIBO might react to its environment. Another module I'd like to talk about is the sound record and playback module. This is great for integrating KIBO in storytelling or role play of various kinds. Kids can record up to 3 sound clips. It might be parts of a story, it might be animal sounds, whatever fits your integration. In the Robot Zoo curriculum, if you have this module handy, we suggest that kids can use it to record animal sounds, which then that can help them turn KIBO into the animal that they're designing. So to use the sound record module, you first have to plug it in to KIBO. Once you've plugged it in, you can hold down one of these 3 buttons to record your sound clip. So I'm going to hold down the square button. Hello, my name is KIBO. Now I've recorded that sound onto the sound module. And the sound module will remember the sound even if you detach it from KIBO. It only has to be plugged in when you're recording or playing. So I'm going to create a program now to just play that sound. The sound record module comes with 3 different play blocks, 1 for each symbol on the recorder, so kids can play each of their 3 sound clips. I recorded it on the square button, so I'll use the play square command. Simple program to just do this one thing. Now when I play the program, KIBO will play back my sound clip.
Hello, my name is KIBO.
Another important part which I'd like to explain is what we call the art stage or art platform. These art stages provide attachment points, little holes, that you can use to attach constructions onto the top of KIBO. So kids might create a construction with recycled craft materials like cardboard boxes or construction paper, and then attach them using string or pipe cleaners. This kind of arts integration is critical to our curriculum with KIBO and to what we think makes KIBO fit so well into all kinds of different curricular areas. Now with just this plastic riser, the stage platform would stay stationary as KIBO moves. But you can also use an extra motor, attach that into the riser, and then attach that to the central socket. And then when KIBO moves, the platform will spin around. This is great if KIBO is a helicopter maybe, or a carousel. The spinning art platform opens up a bunch of different possibilities, but it might be more appropriate for what your kids are trying to build for them to use the stationary one. So either of those are options. Finally, there are some more advanced sensors, the distance sensor and the light sensor. Those are used in conjunction with, again, some more advanced programming blocks, the repeat block and the if block. I won't explain how those work in this video because those are more advanced topics which you probably wouldn't cover during an initial introductory curriculum with KIBO, but you can go to our website where we have additional tutorial videos that cover how to use the additional sensors and the repeat blocks and the if blocks. So now I'd like to shift gears a little bit and talk about the KIBO Zoo, which is our introductory curriculum for getting kids started with KIBO in a classroom setting. The KIBO Zoo consists of 4 guided lessons that introduce kids to building with KIBO, programming with KIBO, and then representing something of their choosing with KIBO. Now, KIBO is designed to integrate into a wide variety of curricula through the ability to build onto it with craft materials, to tell stories through KIBO's movement, through recorded sounds, through the lights that KIBO can turn on. So our curriculum, the KIBO Zoo, suggests that kids research an animal that they're interested in and then use their programming and building skills to turn KIBO into that animal. The curriculum is designed to take about 8 hours of classroom time. The 4 lessons are each divided into chunks. You might run them over 1 intensive week. You might run them over 4 weeks with 2 hours of robotics time in each week, or you might spread it out even farther. If you spread it out even farther, we recommend that you include a bit of extra time to do reinforcement of some of the concepts. Each of the 4 lessons in the booklet take about 1 to 2 hours of classroom time, and they build on each other. They begin with an engineering-focused lesson, where KIBO is introduced. Lesson 2 introduces programming, and Lesson 3 asks kids to start to design their robotic animal. In Lesson 4, they'll continue this work leading up to the final showcase. Each lesson provides an overview of its objectives, a listing of the materials you might need, and an introduction to the vocabulary you might use with the kids. Then you'll find a section of background info for you to prepare you for the lesson. And lastly, you'll find the detailed lesson plan for the unit. Most lessons are structured around an opening warm-up activity, then a circle discussion, usually with a recommended reading. After the circle, kids will engage with the main activity, and you'll close with a technology circle, an opportunity for kids to share, provide feedback, and reflect. In Lesson 1, Build Onto a Bot, you'll talk with kids about robots and their parts. You'll read From Head to Toe by Eric Carle, and then contrast robot parts with animal parts. Students will get moving with the robot parts song.
Connected to the motors are connected to the body. The engineers created a program so robot can move.
For the main activity, kids will build onto KIBO with craft parts. In Lesson 2, Dancing Animals, kids will learn about sequencing, programming their KIBOs. Get them moving with our KIBO Says game, which is like Simon Says, but with KIBO commands. They'll think about how animals move with Move by Page and Jenkins. Then they'll program their KIBOs to dance the hokey pokey.
You put your robot in, you put your robot out, you put your robot in, you do the hokey pokey and you turn yourself around. That's what it's all about.
In Lesson 3, What Animal Will KIBO Be?, students will begin their work on their KIBO animals. Read Rosie Revere, Engineer by Andrea Beatty to get them thinking about the engineering design process. Once they're thinking like engineers, they can start researching their animals, planning their work, and designing their bots. Lesson 4, Refine Your Design, gives the students more time to continue building and programming their KIBO animals. You'll call technology circles as needed to give them time to share and reflect. Finally, their work culminates in a KIBO Zoo showcase, where peers, friends, and family can visit the KIBO Zoo. Students present their creations and visitors ask questions about the process. So, thank you very much for watching this video. We hope after watching it you feel comfortable with KIBO, with how to program it, and you have an idea of how to run the KIBO Zoo curriculum that is our recommended starting pathway for using KIBO in the classroom. If you have an interest in seeing more tutorial videos or seeing more videos of classroom implementation of KIBO, or reading about experiences other teachers have had, we encourage you to visit our resources website at resources.kinderlabrobotics.com. You can see tutorials, classroom stories, activity ideas, curriculum ideas. There's a lot of resources there to get you comfortable and to keep you going with KIBO once you've explored the KIBO Zoo curriculum with your kids. So please have fun with KIBO and good luck trying KIBO out in your classroom.